Okay, question 4. In circle O, chords segment AB and segment CD are congruent. Point P lies on segment AB and point Q lies on segment CD. Angles APO and DQO are right angles. Radii are drawn in as segments AO and DO. Maria must either prove that the two chords are equidistant from the center or that segment OP is congruent to segment OQ. Which postulate or theorem will be most useful in her proof? So I'm going to scan and just look for if there's a proof where two chords are equidistant from the center of a circle. And I'm going to jump up to the front. So the diagram of circle C shows that radius CE intersects chord AB, and prove that segment DE is congruent to HI. Is that similar to what we had? Yes, except for on the other end. So this example is using DE and HI, whereas our example is using the inside right here. So I duplicated the tab and pulled it over so I could look at the picture, because that's what I'm looking for, is I'm looking for a similar picture, because they want to know that O to P and O to Q are congruent. So if you notice, this one is similar to OQ because it doesn't quite go to the end of the circle, and this one is similar to OP because it doesn't quite go to the end of the circle. It is saying that AB and CD are congruent, so I'm going to mark, AB right here is congruent and C to D is congruent. And the other ones that are given is that this is a right angle and this is a right angle. And so we're ending up with pretty similar, the radii are congruent. The radii are congruent right here. The one jump that we are missing is that that FB is congruent to EG, so like we're missing that AP is congruent to QD. However, this is what it's following along this proof is. So I'm noticing that it says we can use the hypotenuse leg congruence theorem, and that was one of the options that we had to answer our question. So that is how I'm going to use an example and why I duplicated my tab, and to look for a picture that was very similar to this picture that I had. So it would be the hypotenuse leg congruence theorem.